This is Jun09 paper 2. Explain why a sound wave does not pass through a vacuum. So 1 mark, just so sound waves need particles to allow sound to pass through. Now you could also put in there need particles to vibrate, you could put in to allow sound to pass by. Describe an experiment to show that sound waves do not pass through a vacuum. State clearly all the observations made. If we just look at the bottom here, you can see there's 6 marks for that. So there's plenty of space there, and they're giving you space there to draw a diagram. So the first thing probably that you should draw there is your bell jar. This is the bell jar experiment. And show that you have a source of electricity. And you've got your bell in here. And label anything you draw, label. So there's your bell. And there's your 2 vacuum pump. And label the bell jar as well. Okay, so they'll give you 1 mark for your diagram, provided everything's clearly labelled. So how are we going to describe this? We need still to get 5 more marks. So first of all, bell switched on. And sound clearly heard. We can also see the hammer hitting the bell. Vacuum pump removes air from the jar. I can't see that, sorry about that. And now the sound can't be heard. But we can still see a hammer hitting the bell. And this just proves that sound can't travel without particles. Now, you don't really need that 6th point, but there's no reason why you couldn't answer. You couldn't answer a question in bullet points like that. And if there's nothing down at the bottom here that says quality of written communication, it means you don't have to answer it in full sentences. If it did say quality of written communication, then you have to answer it in full sentences. So there's 1, 2, 3, 4, 5, and 6. And that's how you get your 6 marks. Here's another echo question. So I think this is probably the 4th echo question you've had on sound, maybe in 4 years in a row. Sound reflects well from hard surfaces, causing echoes. A hall is 50 metres long. A sound is made at one end. How long will the sound take to travel from the source, which is here, to the back wall and back to the source again? The speed of sound is 340 metres per second. So this is a wee bit of a trick. Normally we're being asked to calculate this distance, and we're being told the echo time. We're being actually asked here for the echo time. So it's up to you what way you do it. The way I'm going to do it is I'm just going to find the time to reach the back wall. And then I can double my time whenever I get my answer. So speed is distance over time. And if you arrange that, time is distance over speed. And the distance is 50 divided by the speed, which is 340. And that gives you an answer of 0.147 seconds. But we need the echo time, so we have to double that. It's 0.147 times 2, and that gives you 0.294, and you can't see that. It gives you 0.294 seconds. And the seconds is already there. You could alternatively, of course, do this just by calculating echo time and using double the distance, and you would get the 0.294 directly. So to get your marks there, you're getting 1 mark here. You're getting 1 for the speedest distance over time, and 2 for this, the rearrangement and putting the numbers in. Next question. A radio station transmits waves with a frequency of 200 kilohertz and a wavelength of 1.5 kilometers. Write down the speed of the radio waves. Remember to use the correct unit for the speed of the radio waves. So that's in your answer there. It's going to be a unit mark. You're advised to show clearly how you get your answer. So you've got a frequency and a wavelength. So we'll just write these down. Frequency is equal to 200. Now, it's kilohertz, so it's by 10 to the 3. You can either add 3 knots in the end, or I'm just going to put on by 10 to the 3. And the wavelength is 1.5 kilometers. And again, those are in black to warn you that you have to change those. And so that's also by 10 to the 3. And it's in meters then, not kilometers anymore, but meters. We've added in the 10 to the 3. So your frequency and wavelength, you must be using V is equal to lambda F. And lambda is 1.5 by 10 to the 3. And frequency is 200 by 10 to the 3. And that gives you 3 by 10 to the 8. Now that is the answer you're expecting. Although this is the sound, these are the sound questions, this is actually about the electromagnetic waves. And do you know that all electromagnetic waves, like light, travel at 3 by 10 to the 8 meters per second. So that is the answer that we're expecting. And so you get your marks for your answer. You get 2 marks for doing this, for changing, and a mark for your equation. Funny, in the mark scheme they haven't given you a unit mark there, so they're just expecting you to have it in there.